Hey everyone, this is Lori Silverman with episode 14 of Level Up with Lori. Today's show is called, Is It Possible to Do Data Science or Data Analytics Without Statistics? My guest today is Keith McCormick. He's the author of SPSS Statistics for Dummies. The fourth edition, I believe, is going to be coming out soon. Is that correct? Which is really cool. He teaches numerous LinkedIn Live courses, and he's also a consultant in predictive analytics and machine learning. So welcome to the show, Keith.
Hi, thank you.
Yeah, happy to have you here. Before we get started, because I have a funny feeling that there are lots of new people who are with us today. First of all, welcome. If you are on YouTube or on LinkedIn, please introduce yourself so that we know you're in the background. Otherwise, we don't know anyone. We can't see a soul who's here on Streamyard. So it says that we're having a problem streaming to LinkedIn. This may be an issue on LinkedIn. Okay, so we're having an issue on LinkedIn already. So for those of you on LinkedIn, if you cannot hear me, go to YouTube to see the show, but we seem to be having a problem here. Today, sorry with that. And sorry, Keith, that this is happening to us. Yeah. Again, switch over. I don't know if people can even hear me with that. Hopefully they will. Before we get started, I want to talk a little bit about what this show is about and position it. So Michelle is here. She's as excited to be here from the UK. Welcome, Michelle. And she's on YouTube. Michelle, if you could make a note over on LinkedIn for us, for people to come on over to YouTube on the post, that would be great. Evidently, our LinkedIn connection is not working. I would appreciate that. But this particular show, Level Up with Lori, is to talk about a new area that I call Data Literacy 2.0, which is at the intersection of decision intelligence, strategic thinking, organizational transformation, and business storytelling. And this show in particular is one that I think is actually a pet peeve of mine, for a lack of a better term, I guess. And that is that I learned statistics back in the late 80s, before the term data science, I think, was mainstream conversation. You would know better than me, Keith, about that. And I was showing Keith this morning that I actually have a book from one of the folks who I learned statistics from, Don Wheeler. I know that there's some people in data science who actually refer to Don's work, but I learned the fundamentals from George Box, who was at UW-Madison, from Dr. Deming, Don Wheeler, and Howard Gitlow, who was at the University of Miami, that I also had the pleasure of writing a book with. And so what I see missing today are just the fundamentals being talked about. And when Keith and I connected, he actually approached me and said, hey, would this be of interest to you? And I'm like, because I think he saw my post, and I'm like, oh my gosh, absolutely. This is a topic that I would really like to have. So I'm glad to have you here with us today, Keith. Maybe what we can start out with, as Michelle is trying to get people to hopefully come over from LinkedIn to join us, is talk to us a little bit about when I say statistics, what comes to mind for you, kind of like what your operational definition is, and kind of what sparked your interest in the field itself.
Well, first, I want to thank you for inviting me. And I felt the same way. You know, when we had that first conversation, we were kindred spirits right away. So I started out as a statistics software trainer. So in the late 90s, I relocated down here to Raleigh-Durham. I had done undergrad up in Massachusetts and grew up in Rhode Island. And I was going to do psychometrics. So I was going to go in a fairly traditional, but maybe very traditional, statistics route. That's the psychometricians do psychological testing and all kinds of other things. So end up, either doing something like school psychology, or I probably would have tried to seek out a job at Educational Testing Service or something like that. I was always fascinated with that, and things like even personality instruments and things like that. So I got interested in statistics because I went to an engineering school studying computer science, but we all had to do this big project. I mean, it lasted a year in the social sciences. Usually it was societal impact of technology, that kind of thing. But typically, the research mode was survey work. So it just really started out very simply of just the practical matter of trying to analyze survey data. But as I got more and more into SPSS, I became intrigued. And initially, the SPSS training was just very basic level stuff that I was teaching based on the years that I've been using it as a way to pay the bills during grad school.
Oh.
And then it turned out to be a career, and grad school didn't happen.
How interesting. Well, you and I had a conversation when I think you said to me, remember Minitab?
Oh, yeah.
Oh my gosh, like that takes us way back in terms of the software that was available, but there wasn't that much back then. Again, for those of you who are watching us on YouTube, please introduce yourself so we know that you're watching. LinkedIn has, or Streamyard has informed us that the stream is probably not going to LinkedIn today. I will repost the video up on there. Evidently, we're having some issues with transmission, and it's LinkedIn's issue. It's not our issue on our end, which is unfortunate. So for you learned this all happened when, like circa when?
So late 90s. I relocated down here in the mid 90s, and then the winter of 97, 98. Yep, I'm sure that was it. Was when 97, I started heading up to DC to take some classes. It's kind of a funny story, somewhat entertaining too, I think. SPSS Inc. This is before they got bought by IBM. Minitab is still alive and well, by the way. We'll have to circle back to Minitab at some point, because Minitab is still out there. In fact, they just bought Salford Systems, so that's a separate story we can talk about in a few minutes. But SPSS offered at the time what they called the training subscription. You know, this is late 90s, so everybody was doing classroom training. You would physically travel to training, and that was the only mode. You know, online training existed, but it wasn't widespread or popular. So the whole idea of the training subscription is you would pay a flat fee for the year, a price that would be considered ridiculous now, you know. And I was on a long-term consult with a nonprofit. I was doing some SPSS analysis for them as an external resource. And I said, well, you know, if you pick up this subscription fee, I'll cover my own travel and take classes as I can. I'll promise to keep up to date on my responsibilities. And next thing you know, I was up there for 10 or 12 weeks, because, you know, this was a very different era back then, when they would offer 30 different short courses. But these short courses were 2 days, 3 days in length. You add them all up, it was 30, 40 days. Yeah. Yeah,
but mine was my initial introduction. I joined a consulting firm in January of 1988 and was immediately put into 3 weeks of statistical training. That was just what we did back then, right? We did these tremendous deep dives in the classroom with people. I do want to welcome some new folks who've joined us: Gio Wu, Duke Oaks, and Sandeep Wadhu. Thank you for joining us. Again, we're having problems with the YouTube or the LinkedIn feed, and thank you so much, Laura Locke and others. I think there are some folks on there who are, I'm just taking a look here, if you don't mind. If they can come over, if you can, again, just let them know to come over. There's a bunch of people on the post. That would be wonderful. Then you can take a listen to what we're doing here. Sorry for the inconvenience today with what's going on with LinkedIn. That's why actually I'm double streaming to YouTube at the same time. So talk to me a little bit about people today. You know, there are all these different methodologies that people can learn in terms of statistics within data science. In fact, you and I were just talking about a post this morning where a colleague of ours put up, and he said this whole issue around, you know, someone who really knows data science knows when to step away from data science, when that's not the tool to use. And I would say the same is true of statistics. But you were also saying, as you were reading through all the feed this morning, that if you don't know a particular tool in the hiring process, then you might actually be screened out by HR, which is unfortunate. But in your eyes, we've talked about people who say, I know statistics because I know SPSS and I know SAS, or I know R and I know Python. And talk to me about why that is not statistics.
Well, you know, it's funny because, you know, sometimes I think as a community of analysts, we have to learn the same lessons over and over and over again, you know. Right. So when I started teaching SPSS, and you know, since then I've done more consulting, and I work with people that run analytics teams and so on. So I really don't do software training 90% of my year like I did 20, 25 years ago. Mm-hmm. But back then what would happen is folks would just want to take the basic class, learn the menus, learn what to click on. And then they were like, I'm I'm done. Time to move on. I've learned everything I need to. And unless you also took the theory classes, in fact, we were chatting about this the other day. The regression class was 3 days. It does not take 3 days to learn what to click on in SPSS to do regression. In fact, if you're going to do something very simple, I could show you what to click on in 15 or 20 minutes. So how did we spend the 3 days? We had to spend the 3 days. What are the assumptions of the technique? What can go wrong? What are some real world applications of it? Tell some stories about client interactions and what they started to do, and then they discovered that there was an issue, and then they had to correct it. It's that stuff that's really as much craft. I love that word when applied to this. There's as much craft as just, it's not a recipe. You're not just following a recipe.
Well, it's about the art, isn't it? The art of it. And also what I call deep understanding. You cannot have deep understanding unless you've actually utilized the tool and you understand its in and outs in terms of its application, right? Or its practical application. And so many people don't know that. And I think that becomes problematic.
Yeah, until you, and I always tell people, make sure you're seeking out the right mentors, there's any number of people that could teach you the mechanics of how to do regression and SAS or R or Minitab, or in fact, there are probably people out there that could probably do it in 10 platforms or languages or even more than 10. But you really want to seek somebody out that's going to tell you about the times that they talked to an executive, about what the executive wanted them to do. And then they built the model, and then they reported the model all excited that they had done this amazing job to the executive team. And they said, that's not what we wanted at all.
Right.
Okay.
Right.
Unless someone is mentoring in you in that aspect of it, your education is incomplete, I think.
Well, and that comes back to even something that I've talked about in a previous show on our methodology called Making Smarter Decisions through the use of data. And that is, you really have to have a keen understanding of the business and the ability to formulate the ask in an appropriate manner. So it's not just this general ask, I kind of want to know why this is happening. Well, why do you want to know? How are you going to use the results of what I give you? What are the implications of what you think might be the issue if I give you something different? And what does that mean if I, again, have to confront you with information that doesn't fit your mental model, your mental framework, Mr. Executive, right? I mean, it's all of those sorts of pieces, because you may then decide that what they think you need to do is not what you need to do at all.
And to a young data scientist, confront, the word that you just used, it might seem like a little bit of an intimidating word, but it's the right word. You have to push back a bit and say, okay, I got your email with the model that you want me to build, but in chatting with you now, you say to the executive, I'm not entirely sure that what you're asking for is what you really want. Right. Let me see if I understand. Right. That takes more experience, and that takes more skill. So back in the day, every once in a while, it was maybe 5 or 10% of the folks that we would have in class, not just my class, all my colleagues, because we would chat, during lunch. We would go in the back room to grab the lunches that we had brought to work, and we would be chatting about our classes. And, 5 or 10% of the participants would be, why are you going to the board and, drawing this picture or telling us about multicollinearity or whatever? Tell us what to click on, tell us what to do. Now, graphical user interface style stuff like SAS and SPSS are rather out of fashion now. That's not what people are talking about. Right. They're talking about Python and R. But in some ways, the problem's been exacerbated. There's a lot of good things about doing data science with a programming language, because thinking like a programmer is a good life skill. Okay. And when it comes to do things like interacting with IT or accessing your data or deploying your model when it's done, all these things are facilitated by having that programming mindset. However, there's even more kind of memorization, where's the code, a lot of copying and pasting from GitHub, frankly. Yep. Right? So there's a lot of this. Of course, I know what I'm doing because I just generated a result. I ran the code. I didn't get errors. Output showed up on my screen. I'm done, right? So even more so than I think behind, part of it is it becomes a generation war, right? Everybody should learn the way that we did. But that same thing is coming back again, that it's about the tool and getting the mechanics, not about the understanding.
Correct. Well, and what Gia added to this is she said, and for the rest of you who've joined us, please introduce yourself. She said, it's very true that the mechanics and the recipes of statistics are readily available, but how to do it right and well in the real world is the part that takes a lot of learning. And that means being put into situations and putting yourself into situations where you can ask. Michelle, I think that you there isn't a LinkedIn Live on there. You did, somebody did post on the, I have up some announcement posts that are on LinkedIn, and I know that Laura Locke has mentioned it on one, and I've mentioned it on another, that people need to come over to YouTube to join us. So if someone, all you have to do is search, if I can just do an aside here, search on, in the upper left-hand part of LinkedIn, put hashtag level up with Lori, and you should be able to see all the different posts that I've done on this show. I'm afraid I can't get to them as we're talking here today, but I would appreciate that. Cindy, thank you. Yes, LinkedIn has informed us that they are not streaming today, that they have a problem. So Cindy, I'm so glad that you came over here. I'm happy to have you join us over here, and I'm glad that I'm actually streaming to both services. But if someone wouldn't mind going over to the other posts, I've commented on one. But let me just say here, I have another one here where if you can hold for just a second, I just want to say go to YouTube.
Well, you know, I'm going to, as much as I love LinkedIn and my affiliation with LinkedIn Learning, I want to briefly celebrate Streamyard for, you know, having this technology to simulcast out to more than one platform. You know?
I am so happy too. Yeah. And I actually get the feed so I can put it back onto LinkedIn. Sorry, folks, for all of the inconvenience.
So go Streamyard.
That's right. Go Streamyard. So for any of you who are thinking about like a platform that you want to use for streaming, for podcasts, videos, Streamyard is definitely it because of its simultaneous possibilities. But again, introduce yourself. If you have questions for Keith, please let us know. We're kind of doing a little bit of a slow ramp up here just to wait for folks to come over. So I want you to address the question that is the title of the show like right away, which is it possible to do data science or data analytics without statistics? And I'd like you to talk to both sides of that. So maybe you can take the side first of the people who say, yes, it's possible to do data science without statistics, and then we'll go to the other side, which is kind of where you and I lean.
Well, there's a related topic, right? So if I'm keeping track, we're doing the you can do data science without stats argument first, right? So if I can be devil's advocate, because that's not my own position first, part of it comes from, and it's an extension of what we were just talking about. Part of it comes from this whole notion of the citizen data scientist, you know, that will have a tool that will do the analysis for you, okay? And here's my own 2 cents on this. I think that tools like that can have value, and I don't blame the vendors, they're just doing what they have to do. I think sometimes they pump up a little bit expectations about what a tool like that can be. So if you're going to have some kind of deployed model, it's going to be a forecast, could even be something that drives your inventory. You know, there could be any number of things that are going on. The notion that you're going to have 5 or 6 regional managers all building their own models just seems crazy to me. No, that should be centralized and it should be done, you know, by experts. So what could these tools do? You know, if they just called it self-service BI and not self-service analytics, and I'm not trying to, you know, say the BI isn't important. I'm saying quite the reverse, really. If it's the notion of spotting what's going on in your data and spending a lot of time observing your data, I want as many people involved in that as possible. That really can be democratized. And some of the things even that we've talked about, Lori, that we think are very important about statistics, like getting a sense of how much variation is unusual and noteworthy. These tools are pretty good at that. You know, adding confidence intervals to things. I think sometimes you have to coach people and encourage them to actually apply these tools, right? But they're all in there. So if I was going to have a trend line with a confidence interval or something, I really want to democratize that and have a lot of people doing that. But then when you go the next step and you start building models, you really have to know more than just the basics to make sure that's competent. You know, one way that I put it, it's kind of the funny way to put it, is just because you've added a trend line to a scatter plot doesn't mean that you're doing regression.
Well, exactly. And I want to add something in here that I've talked about in another show. I'm a proponent of what I call decision democratization. We can give people all the data we want in the entire world. And if they are not allowed to make decisions on that data, it's worthless.
Yeah.
And to me, that's a piece of what you're talking about. But the other part of it is that what we have to learn how to do is be collaborative in the decision-making process. I need to know who to involve at each step along the way. So if I'm working in data science, one of the things I have to be thinking about right up front when the ask is made of me is, who else do I need to involve? Who's a part of this group of people? It's not just me doing my work, but it's me in collaboration with people within the business, people within potentially IT, people who maybe have some other analytics background to assist me in this process of getting what's needed to make a decision. So often the process of data ends with publishing data. It doesn't end with anything being done with it or it being used for anything, right? And I think that's the big issue when I say, oh yeah, I can do this without statistics. I'm just gonna clunk through the application that I'm using. I'll have an output, I'll spit it out, and I'll send it on to someone, and I don't care what really happens with it. And that's hugely problematic.
Yeah. So circling back to that scenario that I was just talking about, and we should also be clear that statistics and machine learning are not the same thing.
Yes, correct.
So if someone's going to be doing data science, they really need to know both. There's just kind of no way around it. Frankly, the machine learning piece is probably in many ways the dominant piece. I usually tell clients, the statistics piece is probably 15% or so of the puzzle, but it's a really, really important 15%. So getting back to those regional managers, or maybe they're a VP of sales or something like that, and they're struggling with their forecast. I want them to have a tool where they can explore the data and go, this is funny. Something is not right, because I'm talking to my salespeople in the field. I know what the number should be. So either there's a new trend that I don't understand, or the data is not trustworthy. Something's going on. That person should have a way of interacting with the data science team, because increasingly companies have that, and alert them to the fact that this is strange, but then have somebody that has the time and the training and the tool skill, the tool skill set to go in there and ferret out this mystery.
Correct.
So I'd be happy to have the whole company bird dogging for me, trying to find these strange things in the data. But having all of them working alone, that's the odd thing about it. The citizen data scientist was supposed to open things up and have us communicate more, but it's really walled ourselves off from each other, because the whole notion is everybody's on their own.
Right.
Well, we have limited resources. You're stuck. You better figure this out on your own. And that's a problem. We want more communication, not less.
Well, and I think the job title that has started to crop up to do some of this is called an analytics translator or an analytics interpreter. But I want to expand that to include the steps of decisioning. So to me, there's a bigger issue behind this, is that if your organization does not have a documented process for doing decisioning within which data science and statistics fits, so people understand what the whole looks like and who to involve along the way, that to me is one of the first steps that you need to take on. Because otherwise, otherwise you're kind of hanging out there too. It's like, well, I don't know the organization well enough. What if I'm a new employee? I don't know who to contact. I don't know there's lots of unknowns that can crop in. And
I feel really strongly about this one. And it makes us think, I doubt he's on the call now, but someone that we both know, James Taylor, in his decision management, and, that whole circle of folks that we know. For me, the analytics translator is an important job, but really it should be ideally the head. There should be multiple people that have the skill set, hopefully. But one person that really, really needs it is somebody that's in a role of analytics or data science middle management. And most companies don't have that role. So usually what happens is you hire data scientists because of the technical, skills. Usually there isn't a lot of data scientists managing other data scientists. Sometimes they report up through IT, which is fine, but IT will tend to I've grown to adjust to the fact that it's fine. Anyway, the problem sometimes is that IT will have a technology focus, because so much of what they have to do and what's important to the organization is the technology focus. So they'll want to reduce the number of tools, which creates this tool litmus test problem that we've talked about. So that analytics middle manager, what they really have to do is be staying in constant touch with the business and find out which of these requests are really ad hoc requests, like that there's something weird in my data anecdote that I was just sharing, and then which model should be deployed. And the deployed models are the ones that are really driving the business decisions, like who should be flagged as a mortgage risk or which insurance claims are risky. Machine learning models can do an amazing job at that, but unless you have a good analytics translator in this analytics middle management role, the projects aren't getting routed to the right people.
Well, and I'm going to suggest also, and I know that we may differ on this, is that this is a perfect role for business analysts to play inside of organizations, because they know the business of the business and they should know all the people. They also know what the business processes are, and the work that we're doing ultimately and I had a show on this with Robert Vane a couple weeks ago that I think you may have attended or watched. We have to tie this all back to the flow of the business and the customer journey. This is not all about doing these analytical or statistical exercises independent of the business. And decisions right now aren't being attached to the process flow of the business. And we can talk about those decisions, at the strategic level, the operational level, or the tactical level, right? But somebody's got to be managing that piece of it. And I think that whether that be a middle manager, a business analyst, or someone, to me, everybody needs to learn the process of decision making so that they know how to facilitate it and who to go ask to be involved.
The translator can't be what would be the right phrase. You don't want them to be to kind of jam up the works by having the only conduit by which all this flows. A good analytics middle manager is increasing the data literacy, to use the phrase that you were using earlier, is part of their job. They kind of almost have to be an evangelist for their team and so on, so that they're constantly educating people on how to utilize that resource.
Yeah. And for me, data literacy is different than the way most people talk about it. So when I talk about data literacy 2.0, which is kind of what we're talking about here, it's what's the enterprise core competence that underlies all of this. That's what we're talking about here, is you have to understand the people that are going to be involved, the tools, the processes, things like that, and whether or not we're going to use what the use of statistics is going to be within data science in order to further any requests that we get.
Yep.
So it's kind of this bigger picture. The traditional definition of data literacy is, you just learn how to do analytics as an individual. And to me, that's too narrow an approach for us that we're talking about. So your point is there are people who, how do I convince someone who doesn't believe statistics should be used within data science to kind of come over to the other side?
Well, there's so many good examples, right? So I think the trick is to narrow things down, because I think everybody instinctively knows it's not about all the fancy jargon. Not everybody out there has to learn multivariate analysis of covariance, or know that it's Mankova or whatever. I think the trick is to try to explain that there's a handful of super critical things, and it's not a huge long list, but they're important and they have to be understood thoroughly. So variation is a big one.
Right.
And when we first started chatting, there was a story that I told you that I think you remember was memorable. I was working with that electric utility. Mm-hmm. And they were measuring they were here in the mid-Atlantic, here, well, a little bit south of that, down out by where I am. So we're in a temperate zone, and the reason that's important will become clear in a moment. So they were doing these surveys every month. They had an outbound customer service team that would make these calls, and they were seeing some fluctuation in the calls. So what would happen is, when the customer satisfaction average was high, it would be a really big deal. Like bonuses would be paid out. And I said, was this like everybody gets $50 or there's a pizza party? They said, no, this is like 2 weeks pay.
Wow.
Was bonus. Wow. It was like a really big deal. That would get anybody's attention.
Right.
Okay? And if there was a low satisfaction score in any given month, then there would be a lot of retraining. A lot of I remember the phrase, they said we have to remember to smile on the phone, right? If you're smiling on the phone more, I guess if you physically smile, while you're on the phone.
Yeah, standing up and smiling. Yeah.
But the notion was that's going to get our satisfaction higher. So there were two things that I noticed, and they were both important. And keep in mind that I wasn't looking at raw data. I was looking more like an executive dashboard. So it had really been really processed. I mean, the data had been processed right out of the data, but still my instincts were good enough that I spotted a couple of things. One is it didn't seem to be fluctuating that much. It really didn't. So they were, if they had 92% satisfaction one month and 88% satisfaction the next, there was panic in the streets, and I said, something's funny about that. And it was really not easy to calculate a confidence interval, as simple as it is. Couldn't do it. We had to go back to the raw data because, again, all that stuff had been washed right out. They were just reporting the averages to, 2 decimal places. Right. Kind of crazy, right? To a dashboard. So we had to circle back and do that. And sure enough, if you looked at 36 months and not just the last couple of months, what you actually saw is that it was bouncing around within a band. And it would only occasionally bounce outside of the band. I know a topic that's important to you because we spot it all the time. We spot it on LinkedIn. We spot it in reports. We spot it in YouTube videos. Everywhere you spot this natural variation, and people are in a panic about it.
Right.
As I mentioned when we were chatting the other day, COVID is another example of this. Everybody now, the first few weeks, people weren't figuring this out. But when you're looking at COVID data, something that most of us look at almost every day, we're curious about our states, about our communities. Are things trending in the right way? If you don't do a 7-day moving average on COVID data, you get this big spike on Mondays because the reporting doesn't get posted on the weekend. So you always get this big jump on Mondays. And initially, the journalists were misinterpreting that. They were saying, wow, we had a really big Monday. Things are really trending in the wrong direction. And sometimes it was true, but often it wasn't. So what ultimately happened with this electric utility is when we looked at the times that it did break out of a normal range, it was always in October or thereabouts. Anybody, actually, this would be super interesting if everybody wants to put in chat why they might guess that. Why would an electric utility in a temperate zone, so we're talking about air conditioning and heat both, why would October be, and again, we're not talking Southern Hemisphere here, we're talking October and the US. Why would October be a low satisfaction month? Why was there seasonality in their satisfaction? It's an interesting puzzle, isn't it? Anybody have a guess?
Yeah, I'm not seeing anybody come up here with anything. Has anybody got any ideas? And you're welcome to, by the way, also ask us questions. We will talk about what we have planned unless you have questions to ask us, but I'd much rather have your questions. I don't see anybody coming through. I think they're waiting either for your comments or
fair enough.
I
won't leave them in suspense anymore. It's because it was 90 days after when it gets really hot.
And what happens 90 days
so 30 really days later, you get the bill. And you and your family members go, what the heck happened?
Right.
We leave the windows open, what was going on? Then at the 60-day mark, you get the bill with the red stripe. If anybody's had, college roommates that weren't very good about the electric bill, you've experienced the electric bill with the, with the red, that comes in the red envelope. And then after that, someone turns off the electricity. So imagine getting called by your electric utility and asked, how happy are you with the electricity? And you're in a dark room because the electric's been turned off.
Yeah, well, it's different today, isn't it? Because I get emails constantly from my electric utility that tell me what my usage is. In fact, this is really interesting. I got an email last week that said for the first 4 days of July, now I live in Las Vegas, that my electric bill is going to be over $40 US already. And I went, no, it can't be. It can't be. My whole bill last month was like $60. Something's up. But it wasn't until Saturday evening that my air conditioning unit decided to fail.
Oh, wow.
Yeah. So it was kind of like a leading indicator to me that there was something wrong. But, I didn't know what to look at. I mean, you're like, well, is it because I've been home and I haven't been traveling like I normally would as a consultant, right? Which would be a variable that would factor into this. Is it because, we're now to triple digit weather and that just happened? And so they're doing real-time data collection. And so am I seeing that? I mean, there's lots of queries that I can do in terms of me just asking questions. But sure enough, it was that the system itself that there was a Freon leak that I wouldn't have known about, that was causing the system to work doubly hard or triply hard or whatever to, in terms of energy usage, to try to cool my unit. And then it finally decided on a holiday on Saturday evening to stop working. So there's always those sorts of things, right? We didn't
and for sure we don't want to imply that what's important about statistics is just the forecasting piece, because that's just one example. Because actually that is a source of confusion sometimes that I experience with client executives, is they see everything through the lens of time series forecasting, because that's what they got the most practice with in their MBA programs and so on. So I find it many times they go, wow, data science team, go do some forecasting for me with deep learning. So they've heard these buzzwords, but then they want to do what they've always asked for, but with the new technologies. And maybe a forecast isn't the way to go. Maybe you need a completely different approach.
Gia was saying, why 90 days? I usually get my bill within 2 weeks of the period. I think your example takes us back in time a little bit, correct?
Oh, well, it was, remember, it wasn't just the first bill. It was, they got a shock because remember, this was only about 1 to 1.5% of their customers fell into this category, but they were giving a satisfaction of 1 out of 10, this small group. So we're only talking about 1 to 1.5%. It wasn't that they had a delay getting their bill. They weren't paying the bill the first time, and then it was late. So even today, certainly I agree with you, Lori, and with the comments that they could probably go online and find out how much electricity did I use yesterday. I don't have a Nest thermostat. I guess I'm a little bit old school in my house here. I don't have Nest or anything like it yet, but I'm sure there are ways that you could check on your smartphone how much you used yesterday. What made the 90 days interesting wasn't that they were informed at 90 days, but the service member with the rent showed up and shut them off at 90 days.
Well, not only that, but that's when the phone call came to talk about the satisfaction piece, right?
Yes.
Which was at that 90 days. So I've already seen a bill from, what would it have been, July, that was sky high. Like mine would have been this month. My bill would have been double. And I might have said, I don't want to pay it. I'm not going to pay it. I'll just, take half of it, because they're not supposed to shut your electricity off, but they do in different places. And so I might just pay half. And then next month it's like, I got more again. And then by the time you call me, I'm furious with you, because now you're like you're saying, you're redlining and you're making me furious as well, because you're showing me what's past due. Michelle has a comment. She says, I'm a finance professional, recovering accountant. More and more I realize I cannot support my business unless I have the appropriate data skills. What is the line I draw between what I need to do and what I hand over to a member of the data science team? And how does finance and data science work better together? And I think that's an excellent question.
I agree. In fact, I think it's probably an excellent summary of everything we've talked about so far. So here's my initial answer to this, Michelle, but it's an important one and a big topic too. So I would circle back to what I wish the self-service analytics vendors would focus on, which is giving the ability of everybody in the organization, regardless of department now, we're not talking about the data science team, everybody in the organization should have the ability to access and explore their data, which most companies are already doing, right? But helping out with that variation piece, that's the part that I think everybody in the organization should help spot. When there's something odd in the data, is it a real trend or is it a fluke?
Or to what we would call an anomaly, right? It's a special cause. I mean, from the statistical lingo that I learned years ago. And but I think that the challenge we have is we don't want to make people citizen data scientists, where we say, okay, we're just going to hand it all off to you, right? That's, I think, to summarize what you said earlier. What we need to do is give people a baseline of training, and this is what we did years ago, that helps them to start to interpret their data.
Agreed.
Right? It's the interpretation piece that's the really key piece here. And so that I don't just willy-nilly take an answer that someone else gave me, but I apply my expert business knowledge to the situation. And then with that expert business knowledge, I can say, this doesn't seem right. And oh, by the way, just to add to the conversation here, this is what Keith is talking about, is the use of intuition, which is a form of data based on experience, to say something doesn't seem right.
Yeah.
To me, and everybody in the data community keeps trying to get rid of this gut feel, but this gut feel is absolutely critical to what we call human reasoning. It's the combination of this quantitative data, or qualitative sometimes,
Yeah.
and the intuition that causes us to want to reason through the situation, which is what you're asking for.
I've never used this metaphor before, Lori, but that has never stopped me before. It's almost this is going to sound silly at first. It's almost like wine tasting. If you ever go to like a winery or something like that, and they'll say, "Ooh, I remember I was in France actually, and they were saying that they picked up a little bit of cooked strawberry, in the wine." I said, "Cooked? That's interesting." And then they said, younger wines are more like fresh strawberry if it's this particular grape, but the aged ones are more like cooked strawberry, right? And then next thing you know, you can smell it, even though like 5 minutes ago you haven't before. So what I want everybody in the organization to be able to do is perceive actively observe what's going on in their data in that same way, right? Develop ways to spot things. But then the difference between that and the data science team, when you're actually then trying to prove that this is a trend with inference, to go to senior management and say, wow, this is not a fluke. This is like a real thing, and it's company-wide. That kind of inference where you really try to nail it. Yeah, this really is happening. It's not just a fluke, right? Mm-hmm. That's very difficult to do at the individual level because you have to start to look at other departments and bring in other data. So that kind of inference, I think, belongs to the data science team, and predictions belong to the data science team.
Well, again, it's a team approach. It's if I understand who my team is that I'm working with, so I know who to go to, right? Both from a data science perspective into the business, and from the business back to the data science or data analytics team. And we understand how we're working together so that I help to educate someone in data science, because I'm from the business side, and I've worked across 25 different industries. I've worked with these leaders, and I see the looks on their faces sometimes when they see this. They're like, well, who do I go to about this? Right? They're leading their organizations and they still don't know, who was responsible for giving them what they've got in front of their, in their hands that they're trying to read through. And I think that that's important. But so talk to me now about, so this show is really about statistics being important to data science. And you and I have talked in the past about that there can be some issues, things like the more data, the better, or the algorithm will find the pattern, things like that. So talk to us a little bit about that.
Kind of the algorithm finding the pattern on its own.
Yeah.
Yeah. Well, it's funny because to a certain degree, you'll be surprised that I'm phrasing it this way. To a certain degree, that's true. Okay. Because that is what the modeling algorithms are supposed to do. Here's the part that people don't understand. Now we're firmly kind of in the machine learning side of the house, right? Is people don't understand what data prep is really all about. People think that preparing the data is just about cleaning and formatting. But people that know their statistics know that part of data prep is also understanding the provenance of the data. And the provenance of the data when you're doing statistics is very different sometimes than when you're doing a machine learning. Because in statistics, very often we have what we're trying to figure out, things like a drug study, let's say, and you're planning the analysis, then you're going out to collect data.
Right.
The machine learning data is just lying about, so to speak. At least that's the way we think about it. It's just there. It's a found object from the normal course of doing business. So here's the mistake that people make. They think they can just feed raw data to the algorithms to find the patterns. And you totally, totally can't. That people forget that what data prep is the equivalent. Data preparation and machine learning is the equivalent of planning the study in statistics. It's when you're deciding what data is relevant and whether the data can be trustworthy and what data you keep. So a couple of rapid fire examples. I apologize that this is a bit of a morbid example, but it's one that everybody can relate to. So let's say that you are trying to predict if someone's going to be a 30-day readmit, which is a terribly important thing that you need to predict in healthcare.
Right.
Okay. Now, we're not, these days everybody's mind is on, things like COVID, but I'm thinking more about something like Somebody with a chronic illness, they might have diabetes, or they might have back trouble, or orthopedic issues. Could be any number of different things, right? Well, since the Affordable Health Care Act, for sure, but certainly probably behind that to some degree as well, if someone returns to the hospital with the same diagnosis within 30 days, federal plans, among other things, won't pay. So this is
in the US.
Super important thing. Yeah.
Right. I just want to
in
say.
fact, please say in chat if anybody is in healthcare analytics or in healthcare, because I'm sure if you are, you'll be able to relate to how important this problem is. So what's an identifiable group of patients that when they're discharged from the hospitals don't need a risk score because they're not going to be readmitted with the same diagnosis in 30 days? And I warned you that it's kind of morbid, right? But the problem is, if you were to take those patients that have died and put them in the model, a lot of machine learning folks that are earlier in their career go, I can't take anybody out. It's going to bias my analysis. But that group is never going to be scored at deployment because they don't belong to the group of interest, which is there a possibility that this person's going to come back with the same problem in 30 days? In other words, they haven't been treated effectively, right? So, and the same could be true for any number of things. Like when I was on a cell phone churn project, there were some folks that had to cancel their plans because they were mobilized in the military. There was a special code just for that, military mobilization. And it was, 0.6% of 1%, 0.6% of the, Duke phrased it as
the
horizontal ones. When it's lighthearted like that, it's a little bit less morbid. But anyway, there's a special code for the military mobilizations. It was less than 1% of the data, but you don't bias by taking them out. You bias by including them, because the reasons that people are mobilized are not the same reasons that people switch from AT&T to Verizon. So your list of important variables is going to be distorted by that. So, yeah.
Well, we're going to have actually, if we take this worldwide, we're going to have a really interesting issue just on this point with COVID, because we do not understand what the long-term implications are of a singular illness, and multiple mutations of it to people long-term, right? And that's a question that's starting to get asked, because we're starting to see readmissions that are happening, but they're happening for different things, and we don't understand if there's a relationship between the original illness and what's showing up now, or if there is a variable that's lurking, like you said, diabetes, heart issues, and other things that might enter in. For example, I just had a friend who was hospitalized for COVID, and last week, Thursday, and he's very young, he suffered a stroke. And, and it's like, okay, so what was it, his liver, his kidney transplant from a couple of years ago that caused that? Is it that he had a stent in his heart? What's going to happen to him now? What does this mean long term to this new illness being added, right? I mean, these are the sorts of conversations that people need to start having, right? But they're not easy conversations. They're very complicated and complex.
Yeah. So for instance, the machine learning person in me would want to separate, the data from people that have not had it yet and the people that have already had it. And I'm certainly not just suggesting that you would discard the ones that already had that, but you probably have to do a separate analysis of them. Now, when I tell this to my machine learning clients, they'll say, wow, well then by extension, why don't we analyze older and younger, male and female, like all separately? The trick is if the structure of the data is completely different. So think about what you're doing. If you're trying to figure out who's at risk of getting COVID, you're looking at things in their environment, ways that they might catch it. Did a family member have it, right? You're really looking prior to that moment that they were diagnosed. If you're looking for the ongoing health challenges that somebody would have, you mentioned a couple of, pretty scary ones for sure, but a really common one apparently is lung scarring. I mean, it's not even rare, it's downright common among people that have had it. And the COVID is just such a scary topic, isn't it? Anyway, but this notion, people might have lost 10, 20% of their lung capacity, maybe forever. No one knows, right? Right. So, but anyway, think about all the data that you'd have to collect on them. The very structure of the data would be very different. So that's actually a really powerful example of when you have to separate the data and analyze them separately. And how the data that you keep in and the data that you take out can introduce bias, gets very subtle. So you really need people that do this all day to be worried about things like bias and stuff like that. But spotting something strange, everybody has to cooperate. That's kind of your way of being a corporate citizen, right? It's saying,
right.
the data that I see every day, I'm going to alert my colleagues to things that just seem out of place, because either they're wrong or we're in the middle of a new trend, and either way, we have to figure that out.
Well, and I think that's, so let's take that example a step further. That's what physicians are doing, right? Physicians are saying, and I mean, hospitals do have, data scientists who have the statistical background on staff, and they're saying to them, I'm seeing something weird. It's like when I saw an article recently about all of a sudden people are diagnosing with blood clots and multiple blood clots. And the doctors are saying, is this something that's related? Could you start to check this out for me? How many people have we had come in that have had this? Well, we haven't been looking for it, right? I mean, it's all of these different variables and risk factors that someone can start to call out for someone else behind the scenes to start saying, what's the meaning? What does this really mean?
Yeah,
what are the inferences? By the way, Tony said the structure of the data, yes, drives the integrity of what's reported. So she was confirming what you were saying.
Yeah. Oh, for sure. But also, Tony, think that in these machine learning things, we have to force feed it these flat files. So it absolutely affects the reporting. But your comment was on something else, Tony, but you made me think of something else. So I'm not responding necessarily to your comment, but you triggered something in my mind, which is one of the reasons that I think in the machine learning world that we're hesitant. Statisticians know, by training, that if you take out the missing data or do any kind of intervention that alters the data, that you're potentially introducing bias. So they're super careful about that.
Right.
But as I've been trying to, show, that skill is super important in machine learning, but it's kind of different in machine learning too. Sometimes you have to take out some of the data. So this also, I think, raises eyebrows on, let's say, a BI team. I think it's typically a problem for a data science team and a BI team to be the same team, because they don't generally enjoy the same kinds of projects. Their backgrounds are very often different. You'll have people that cross back and forth. They're close enough that people will be cross-trained. They'll bounce back and off between the two teams. But I've met a lot of machine learning folks that just BI projects that aren't their thing. Right. And then they're just not happy in their jobs and they end up leaving. But think about this for a moment. Do we take out data like the Duke's phrase, the horizontal, patients? Do we take out data like that in last month's BI report? We do not, because if we had a certain number of patients last month, the number of patients in the data should be the same.
Correct.
Okay. But keep in mind that what I've been talking about in machine learning is we're building a model that's going to be used, and it's going to be used for a purpose. And that purpose is going to score data when the model is built. So if it doesn't look like the data I'm going to score, it needs to be taken out. Its inclusion will actually bias the result. Yeah.
So it requires a different level of understanding about the use of the data, if I'm hearing you correctly.
Absolutely.
And therein lies, again, I think the level of education across teams and across functions. We don't talk about these sorts of things. It's like, why am I including it? Why are you not? It's like, well, you don't understand. Yes, I do. I understand, given the mental frame of reference I'm using, which is statistics and data science. You're talking about BI, and someone who does data analytics or very simple data analytics might have a completely different understanding. They might just be trying to visualize the data, and then you're looking at the visualization of the data going, why is this different? Why is this different than what I'm getting over here? Right?
Yeah. So I don't want to scare you and the others with just a few minutes to go, but I've met a lot of machine learning practitioners that know a lot about what they have. They know their tool, they know the mechanics of their tool. They know a lot about machine learning. But if I ask what I think is an innocent and straightforward question, like your tool of choice, how does it handle missing data and what does it throw out automatically? They usually don't know and can't even show me in the help or whatever. They can't even walk me through where they would find how that happens. And unbelievably, I've worked with clients that have 100,000 records, and 0 records were being sent to the algorithm because every row had something missing, which actually in real world data happens. But they didn't even know that their software was automatically throwing rows out. So that stats training really get you to focus on this potential sources of bias and the provenance of the data. And machine learning is its own thing. There's a whole skill set over there as well. But if you've got no one on the team that knows their stats, you won't have anybody advocating for, did we throw out too much? Did we not throw out enough, right? Are we using the right data?
Well, I think there's two types of thinking that enter into what you're saying. One is critical thinking, and the other is strategic thinking. And it's not, again, just the blind use of a tool or the blind, use of copying and pasting. It's really trying to understand what's going on and the implications to the business of that business.
Yeah.
And taking it further. With a few minutes left, I wondered, we haven't gotten questions this time. It may be that we just didn't get a lot of people who transferred over from LinkedIn. Questions that you might have for Keith before we sign off in about 5 minutes. Gia, Tony said this discussion is very helpful, and she capitalized the very, and Gia said, you really do need to know your data. And I agree 1,000%. It's not just the data. You have to know the business. You've got to understand the use of this data. And I think to me, that's the decisioning piece of this. We sometimes get so focused on the input, which is the data, that we don't think about this back end, which is what the heck are we going to do with it? And who's trying to do what with it, right? Which is what you're talking about, which is the contextualization of the situation, and getting a good enough handle on that so I know how to proceed going forward. And I know which sorts of tools to use.
There's a couple of things that I want to mention before I forget, Lori. Please. One, I don't think that I've mentioned to you yet, which is I've been helping an organization called IADSS. I think anybody who's chosen this topic today is going to find this interesting. So it's IADSS. And what they've done is they're trying to define data science to better help employers and aspiring data scientists and so on. And right now they are doing, if any of you know any aspiring data scientists out there, they've just started doing a survey in the last few days, and it's time sensitive because what we're trying to do is collect data on as many aspiring data scientists and how they define data science and what education opportunities they sought out. Because at the Knowledge Discovery and Databases Conference in August, there's going to be a half-day workshop. And this organization has been working on this for 2 or 3 years now, just trying to hash out what are the components that make up a data scientist and data science. And obviously this topic is right at the heart of it, because you're going to see a huge difference between data scientists that are 20-somethings and data scientists that are 50-somethings on how much importance they attribute to statistics. So really only by doing these surveys and asking, in your Python boot camp, did they cover any statistics or, this kind of stuff? It's only through the survey that we're going to sort this out. So please seek that out. If you follow me on LinkedIn, everybody, you'll be able to see it in my feed. And I really would urge you to seek out that survey.
Well, and we can put that up when we transfer over the video over back to LinkedIn. We'll put that up as well in there. And I want to come back to your comment, though. I think it's because statistics was stressed in the 80s and early 90s. There was a huge push for statistics that came out of the quality movement, that came out of Six Sigma. Yep. And so people who, my colleagues who were statisticians back then that I supervised are now call themselves data scientists, but they are grounded and steeped in statistics. Today, that's not where we start. And if you look at even a university program, you don't often see the statistical background or even any classes in there. We have a couple of other comments that have come up here. Tony's talked about her interest is with variability and what we do with it, exactly what the two of you are referencing. And then Michelle said, thank you so much. Great discussion. She said, I'm embarrassed to say I thought data science was a new discipline. It's been around for how long?
Well, it kind of is, kind of isn't. It's really that what we're talking about, of course, is not new. We've been doing this kind of stuff our whole careers, which is more than, it goes a lot further back than 2011, 2012. But around that time, there was a Harvard Business Review article. It was the famous sexiest job in the 21st century article. That was right around that time, around 2011, 2012. It was in Harvard Business Review. DJ Patil, who was chief data scientist of the US for President Obama, right? That was a position that was created and then, didn't continue, but it was a new one. It didn't have a, long history. And then Tom Davenport, who wrote Competing on Analytics, among many other things. They co-authored that article, and it went viral and completely took off. So the phrase data science, Michelle, is indeed new, but the whole notion of what it is basically statistics and machine learning and a little bit of IT parallel systems kind of stuff, mixed in there. And no one can really agree on what the recipe is. But the phrasing really dates back only to that article, so less than 10 years.
Well, and now I want to add something on top of it. I want to add the whole field that's being created by Lorian Pratt and Kazi Kasparov at Google has been promoting this as well, which is decision intelligence, which is, they say, is the combination of data science, management science, and social sciences. So now let's get even more kind of like I would say a blending of all of these different things, and how do we tease them apart? I don't know if we tease them apart. I tend to be more on the decision intelligence side because I'm trying to get all of this, I don't care what you call it, to be used. But to your point, it takes longer than 10 years sometimes, I think, when things are new, to actually solidify and to say, is this really a field? Is this a career choice? What are the competencies? The individual competencies, that's what this study sounds like it's looking at, right? What
I love the comment. What is data science needs a k-means clustering, which is exactly what will the analysis technique that will apply to the survey data, because you're exactly right. People disagree on this. So what we really have to say is 6% of respondents think it's this, and 17% of respondents say it's that. And k-means clustering would be exactly what's that like. I also agree with you about the decision science. We could probably do a whole talk on that.
Yeah,
we could have a really cool panel on that. We know a lot of folks that work in that area.
Well, and Lorian's work is in decision intelligence, so she even calls it something different, which is, I've done a couple shows on that already. So if anyone's interested, they can take a look. We are at the end of our hour. I'm so appreciative. As I said at the beginning, for those of you who may have missed the beginning of the show, Keith's the 4th edition of his Dummies book, SPSS Statistics for Dummies, is coming out fairly soon. He teaches has a tremendous number of courses on LinkedIn Live, where he actually, I was watching some of them myself this past couple of days, that really takes a deeper dive into how do you think through all of these things, and so that it doesn't just become a rote sort of exercise, that we really start to understand why things are the way they are. Anything that you'd like to add before we sign off?
Well, I love that Tony asked this last minute question on the variability, and there's so much to say there. If there was, you just mentioned, my courses, and thanks for the compliment on that. If there was any course that came the closest to what we've been talking about, it's probably my regression course. And there's a lot in there, Tony, about looking at scatter plots, and is this variation real or is it a mirage? And that whole, Laura, you can appreciate that. The whole is it real or is it not is so fundamental to what we
but that goes back to this what I held up earlier, right? Don Wheeler's book, Understanding Variation.
Variation and chaos, right there in the name. Or you may know, what was the guy that does 538? He's the poker player that now does political polls and stuff. I've got the book right back here, but he wrote a book called The Signal and the Noise. Same idea, right? Is this variation real or is it noise, right? Nate Silver is his name.
Right. Well, and the challenge is that you have to know that in order to be able to report out on the data properly. It's not even set up your study, but it's to be able to report out on it to executives.
Correct. Yes.
Here are the insights that I see, or at least that I sense are out there, and then what is the meaning of that? I focus
on the modeling, but absolutely, this understanding the variation affects reporting too.
Absolutely. Thank you so much for joining us today. I'm sorry about the problems, and thank you to all of you who have come over to YouTube. I'm glad that we had a backup here, and I'm going to get the video off of Streamyard and put it onto LinkedIn so anyone else who wants to watch can. And Duke has one final comment. He said the same could be true about risk management, understanding uncertainty and variation, and you are absolutely correct. That is an area that we need to look at as well. So Keith, thank you so much for joining us today.
It was a lot of fun. Thanks, everybody.
Thank you. And thank you to all of us who've joined us. And if you want to watch, if you missed part of it, I'll put it up on LinkedIn, or you can watch it. It's already up on YouTube. You can watch it again. There are other shows under the Level Up with Lori moniker. If you want to take a look at those at all, that would be lovely. And we'll catch you next time.
Thanks, everybody. Thanks, Lori.
Bye-bye.